So my expectation is this. Each and every one of you are at least the assembly on Friday next week. The assembly will happen right before this class period. And then we have this class period. And just think of that. So put this vision in your mind. What you just heard on the wall, that was pretty loud. Sounded pretty cool. Imagine Mr. Peterson hitting the drum kit, me having the entire drum line in there, getting everybody standing going. Now, the lower level bleachers are the ones to be on, right? The ones up top are cement, so you can't hear them as well. So my plan. So we're gonna rip it, all right? Don't disappoint me like 2 years ago. There was nobody at our assembly. Yeah. We're in there, like 7 people. 5 of them are speaking. All right. So. Dang it. So let's get homework out from last time. That would have been the trig, right? Yes. Trig A. Let's get that out.
You should give us extra credit if we show up to the assembly.
No.
I thought that's the lesson.
So some of you do need the opportunity to finish. Some of you do need the opportunity to finish your test, so you need to come see me sooner than later. Now, just a few things to think about. Let's just talk about next year. What should you take next year? Okay? If you have an A or a B, okay? If you have an A, this counts for you. If you have a B and you've needed extra time on most of the tests this semester, then you're falling down in this category, B, C, D. I can do the alphabet. Okay? So if you have an A and a strong B, and your strong B isn't because you were taking extra time, okay, because pre-calc, it's not going to happen, okay? Unless you have, an IEP or 504 that says you get extra time. It's not going to happen. So these kids, if you did not need extra time for the majority of the quizzes this semester, you should think about doing pre-calc and or AP stats.
That's me.
And or.
Is AP stat really hard?
No.
Oh, then why is it AP?
It's February.
Because. All right. So I would recommend that. So that would mean that if you're in that category, you're taking 1 or 2 math classes next year. Okay. Now, if you are a sophomore and this is where you're falling into, you don't necessarily think about double M because we have enough math classes to get you along. Of course, after pre-calc, that'll take you to Calc AB, which is an AP course. Okay, the reason they call it AB is because calculus is 3 semesters in college. You have Calc A, Calc B, Calc C, or Calc 1, Calc 2, Calc 3, depending upon what school you're at. So this would be after that. What comes after AP Stats? There's nothing after AP Stats. It's a completer class. It's done. Okay? If you're falling down in this range, and so this is the B who needed to keep getting more and more time, this is where you need to start looking at the semester classes. Now, okay, so we have the semester classes. So you have college trig, you get college credit for it. College algebra, you get college credit for it. How college credit works is it comes through CU. When it comes through CU, it doesn't mean you have to go to CU. You can transfer your CU grade to any university in the United States, and they will accept it. Okay? And then we do have a 1 semester stats class, and then we have business calculus. Okay? So these are all 1 semester in length. Now, somewhere in here, like if you're doing this, totally good. What comes after those? You can do those, but I would also recommend AP Stats. If you're just like, dude, math isn't my gig and I need an easy senior year. When it comes to your senior year, if you're looking for the total easier way of getting there, like if you happen to be on this track and you're like, oh my gosh, I'm so done with algebra, your senior year, we do have stat analysis, which is a 1-year class.
Thank you. None of my teachers will tell me what to take next year. That's going to be the easiest class.
So,
yeah, my
teacher told us. Yeah, Mr. Anderson teaches this. Does a great job with it. He's got a great curriculum, and I heard there is not any homework.
He said it's like, yeah, it's incredibly easy.
It is, but it gives you a really good view, and it allows you to So any type of stats class that you take is going to really better you later in life. Meaning this. You won't have somebody coming with you and giving you just raw data saying, hey, the sky is falling. Look at this data. Whatever. So that should give you some idea of what to take. So
what classes are you teaching?
Huh?
What classes are you
I don't know. Math.
Yeah.
Wow.
Nah, he's teaching history.
And then I am certified to teach history, so I could take it. Yeah. Yeah. What?
So like, is college credit just like you don't have to do that class in college then?
Yeah.
Right.
Nice.
You've done it when you're in high school.
Is pre-calc and AP stats college credit as well?
No. AP stats, any AP course, you have to take the test at the end of the year. If you score a 3, 4, or 5, that's where you start earning college credit. A 3, 4, 5 is basically a 60% on up. So, and it depends which school you're going to. Like Stanford will accept only 5s. CU will take 3, 4s, 5s. Things like that. So it just depends where you go. Yeah.
On a scale from 1 to 10, how hard is AP stats?
7.
Oof.
I think it's
I think
it's easier this class. I think this class is about an 8.5.
Really?
Yeah.
The
You
class
say
is
a lot of
hard.
things are easy, so it's like that's easier than this.
It's a different way of thinking. You are doing a lot of analytical thinking to say, yes, this is good information. No, this is not good information. So it's an argumentative class. So which is good. You're developing an argument for or against information. Yeah.
Is college algebra basically just like algebra 1 and 2 again?
No, it's basically a faster version of this class that you don't go as in deep on the concepts. It's this class in 1 year at about 70% of the depth of material.
So
you can handle it. But you get college credit for it, which is cool. You get both college and high school credit for it. So
that's a year long or a semester?
Semester. So college, so these 4 classes are 1 semester.
Okay. Pretty cool.
So does that give you a thing? Now, some people have asked, hey, can I make the jump from here to go up to honors? No. You will have missed. You can't go to honors pre-calc. Okay? You will have missed way too much trigonometry because the class they're in right now is honors algebra 2 trig. The amount of trigonometry they cover versus what we cover, they do not come close. So you would be completely lost. Okay? And it's not fair to do you, and it's not fair to do the teacher when you go in not prepared. Some of you are going, yeah, but I'm an honor student. Well, then you shouldn't have been in here. I'm just saying. I'm not trying to take away from you. For whatever reason, you are assigned to be in this class, which is wonderful. I don't regret having any of you in this class. I love having you in this class. But some people, the jump that should have taken place to go to honors would have been from accelerated geometry taken this year being honors. The jump now, you are about 30% behind where you should be. And then people saying, oh, I'll just figure it out during the summer. Really? No, it's not going to happen. So, don't mean to crush people's dreams and aspirations. It doesn't mean you can't be a math major, an engineer, or a doctor if you don't go to the honors track. I will tell you that our accelerated track in this high school is as fast as the honors track in other high schools. Okay? So when you take, and you want to know who knows that our accelerated track is pretty much the honors track? Every college and university out there. Okay? Because anytime they get his transcripts going, oh, this person went to Cherry Creek High School, they go to the state of Colorado, look for the #1 high school in the state, see Cherry Creek High School, they're like, dude, done. Yes. I am dead serious. I taught Honors Algebra 1, I taught Honors Algebra 2 at Chaparral High School, and I cover more in this Algebra 2 class than they do in their honors down there.
Weird. You should give us like
No.
credits.
No, you get a Cherry Creek stamp. All right. Does that help you? Good? Yay?
Yep.
Questions on the trig homework. It was trig A, yes?
Yes.
Which was somewhere in here. Trig A. Any questions on there? Last two on the back. Which one? 24, 25? Okay. All right, number 24. All right, so we know the side opposite of the 60. So if I go this way, I have to divide by √3. So it becomes 9 over √3. Rationalize, that's 9 √3 over 3, which gives me this side being 3 √3. This side is double that, so it becomes 6 √3. And we're done there so far. Is that all right so far? Yeah. All right, so this is the opposite side with the relation to theta. This is the adjacent side. And, of course, the hypotenuse should stick out for you. Okay, sine, some old hippie. So opposite. So I get 3 √3 over 6 √3, which reduces to 1/2. Is that okay so far? Cosine is caught another hippie. So adjacent over hypotenuse. So I get 9 over 6 √3. We can reduce that and rationalize. So I'm going to multiply top and bottom by √3. So on top, I'm going to get 3, and that's a 2. Wait, I just lost. Oh, let's try and thought. 9 over 6 √3. Sorry, I tried to do too many things at once in my head. So that gives me 9 √3 over 18. So that cancels. That becomes √3 over 2. This is √3 over 2. Tangent becomes another hippie. So 3 √3 over 6 √3 reduces just to 1/2. This is 2 over 1 then. Excuse me. This one was 2 over √3, which is going to be 2 √3 over 3. And then this one will be 2 over 1, or just 2. Nice. And the other one you do the same way. It's a 45, 45, 90. So on the number 25, if it's a 45, 45, 90, and I gave you the hypotenuse, that's just 10, and that's 45. Right? If I go backwards, I have to divide by √2. So that gives me 10 √2 over 2, which is 5 √2. I get 5 √2 for this, and then just base it off of that. And I drew my triangle upside down, so I apologize. So, but again, that's how you would go about those two problems. All right, names on that. Pass it up, please. Buddy, you're a boy. Be a big man. Yo, dog. You not here, Dick? Hey, man. What's going on? Yeah.
You should do it in actual Japanese next time. It is in actual Japanese.
You can't ask me about it.
No, not about that one.
Okay.
Yeah.
Okay.
Yeah. Are you here early on Monday?
See if anyone can pronounce it. How do you even read
Where's your fifth?
Japanese alphabet? Just being real lame and being like, have a chill day, but like, sometimes you need to spruce up life.
Spruce?
Yeah.
Not sure it's wrong to have.
A little positivity is chill.
All right.
I don't know. Think of it as you will.
Ready? Plenty of time.
I just don't know.
Okay. So I imagine, let's see, an accelerated, yes, we did teach the unit circle a little bit. We're going to build upon what you know of the unit circle. Again, the unit circle is the way we put the x and y axis and we superimpose a circle with a radius of 1 over top of the xy axis. Okay? So this is basically all we're doing with, this is all we're doing. Looks like you've made a target. Okay? That's all we're doing. We're going to work with this. Okay? So let's build upon this. So I have my coordinate plane. It's also called the Cartesian plane. We have an x and y axis, and we have quadrants. Okay? And the quadrants are labeled 1, 2, 3, 4. So it goes a little backwards of what you might think. You want to know why the quadrants are labeled this way? Because Descartes, a mathematician way back when, created this. And Descartes was left-handed. That's the only reason why we go quadrant 1, 2, 3, 4 in that order. Okay? And being he is the founder of calculus, we abide by it and we don't change it.
Left-handed dudes for the win.
Okay. So you're sitting there looking and going, how does that work with it? Yeah, think about it left hand. How? Okay? So I have a x-axis. I have a y-axis. And then you have 4 quadrants. And then you have the axes lies between the quadrants. Is that okay so far? Can I move on? Yeah. All right. So find the measure of all 3 arcs. So you know that a circle is how many degrees? 360. And this little Jim Dandy here means what?
155.
I didn't count.
That's 90.
My bad.
So how much?
155.
155? Do we agree? Okay. Yeah, I'd go 360, subtract those. Minus 150, minus 90, and it's what?
145.
145? Did we verify that? Or are we just shooting fish in a barrel?
I'm just.
Someone got a calculator? Y'all got
It's
phones?
definitely 155.
155?
No, I mean the other side is 145. Right?
Just get the calculator out.
But it's 360 minus 205 is 155. Like I said, Sam.
My bad.
God.
Sam.
Hey, math isn't my strong suit.
That's why we have calculators, and if you have calculators out, then you can't be critical of people who are getting them wrong. All right, so we good? Okay, and so that works. Okay, so then we create this unit circle. Oh my gosh. I have a video to watch.
Are we gonna do radians now and all
Yeah,
that?
let's watch a video.
I mean, any video could be better than that video they made us watch in history today. It was like.
All right, I have no idea what this video is. I'll turn the speakers on. Let's take a look.
What videos did you watch? What video did you watch?
All right, let's see what this is. Here we go. We're going off screen.
What?
How long is it?
Like 20 minutes.
Like 5 classes.
No. There's a video. There's like 20.
Where's the video? I thought it was a video.
Yeah, it's just a website.
You can just.
Oh, that's no fun. I don't want to do it. All right.
I'm just gonna take it.
All right. Some of you are starting to talk a little too much.
No.
That's just a subtle hint to quiet down. All right. So a circle with radius 1. You still with me on this? It's centered at the origin. That's what this is. And then we have 16 angles that we work with on this particular unit circle. So we're going to start out We're going to start out with degrees. Degrees we will convert to radians. The difference between degrees and radians is this. It's like Celsius and Fahrenheit. Okay? Different way to measure. That's all it is. It's nothing like magical about, oh, it's in radians. No. It's just a different way to measure. Okay, we show both because we need to prepare you for calculus. So if we start right here, this is our starting point, and our circle goes this way. So this is 0 degrees. And then we have to think about our two special right triangles. One's the 30, 60, 90. The other is the 45, 45, 90. So this is a 30-degree angle. This is a 45-degree angle. The 30, 60, 90 also has a 60-degree angle in it. So this becomes a 60-degree angle. And then we get to 90 degrees. Everyone's still with me? Okay? So, this line here, let's see if I can do that as this line here is what we always take our angle off of. So it either comes up like this, or it comes up like this, or it comes down like this, or it comes down like that. I had to finish my dance.
Heard the song earlier, it was great.
Ooh.
All right, so all my angles come off this. That's a 30-degree angle. That's a 45-degree angle. That's a 60-degree angle. That's a 90-degree angle. Okay? I'm going to keep going this way. So that's going to give me a 120-degree angle. Okay? 135-degree angle. 150-degree angle. And this is a 180-degree angle. Okay, so we're just going this way. As we continue to go around this, we're going to come down here. So this is our 30-degree angle in quadrant 3, so that's 210 degrees. This is my 45-degree angle in quadrant 3, so this is 225 degrees. This is my 60-degree angle, so that's 240 degrees. And then this is a 90-degree angle between quadrant 3 and 4, which is 270 degrees. And as I come around, I am going to go 30, so that's 300-degree angle as I continue around my circle. This is a 315-degree angle. And this is a, do what? 330. And then I come back right to here, and I have 360 degrees.
Nice.
Okay? And it keeps going round and round and round. Okay, so if you had a 400-degree angle, you would go around the unit circle once, and it was 400 degrees, it means you go 40 degrees more, so it's lands between the 30 and 45, somewhere closer to the 45. Does this seem okay so far? So again, it's left-handed the way it is. That's how we base it. You had to start an orientation someplace, so it started way back 400 years ago. We don't change it because this is what is accepted worldwide, which is great. Okay. Finally, the world agrees on one thing, and it's called math. Okay. Now, as far as miles versus meters, that's a whole different story. So the science community gets to deal with that. Okay. Can I move on?
Also Fahrenheit and Celsius and kilometers and good stuff.
The nice thing with Celsius, when they created that, they said, hey, the boiling point of water is 100. This freezing point of water is 0. Go to Fahrenheit, you have to multiply everything, was it by 9/5 x plus 32. And then you get,
like 32.
So 32 becomes freezing, 212 becomes boiling. So why didn't we base 0 and 100 off of the most abundant source on Earth called water? I don't know.
Explain the system. And the system is every country but ours.
Unfortunately, it's caused havoc in space exploration.
Nice.
Because, no, not really nice. We're talking billion-dollar errors that have taken place because one country has it in kilometers, one has it in miles. I'll let you figure out what country did it in miles.
This is why NASA is dangerous.
Oh, yeah. All right. Angles who share the same coterminal angles, initial side and terminal side. To find coterminal angles, what we do is, again, we base it off of here, how far we rotated off of here. So over in this region, we base it to here. Over in this region, we're going to start basing it coming up this way. Down here, we go off here, and down here, we go off there. But our x-axis is kind of our base. We will get to a point where we're actually going to start drawing triangles in on this, and our triangle will always come off the x-axis, okay, and falling in quadrant 1, 2, 3, 4.
Nice.
All right, so if I wanted to find what this angle, this 405 was right here, it would be 360, and then you're just going to go 405 minus 360. Of course, I didn't line things up to save my life. It's a 45-degree angle. Okay? That's all you do. Pretty straightforward. And then list 3 different coterminal angles for each given angle. So think about a 30-degree angle. I'm going to roughly draw on a 30-degree angle. Are we close? Seem okay? All right, ready? So if I go all the way around 360 plus that much more, I get to 390. Is that okay? Now I can go all the way around one more time, which is great. Or I can go this way. So I can go 360 and stop at 30 degrees, which gives me negative 330. Wait, why is it negative? Because I want clockwise. Counterclockwise is positive always. If I go the opposite way around the circle, so if I went, like I just said, this creates a negative situation. Okay? So negative 330, 390 degrees, and 30 degrees are the exact same angle you're talking about with the unit circle. All right, so let's create our 335. Our 335 is like over here. So it's actually comes up off here. That's 45-degree angle right there. So that's 135. How did I figure that out? Well, all the way around here is 180. If I back it up a little bit, I have to back up 45 degrees to get to 135. So if I wanted to figure out another coterminal angle, I could go 135 plus 360, and that gives me 495. So that's all the way around the circle and back up to that. I could also go this way. So it's negative 180 with another 45, so negative 225 is the same. So these both match up with 135. 10 degrees, well, 360, that's 370, or negative 350. Okay, 180, so we go to 540, or negative 180. 50-degree angle, 360, so that's 410. Go the opposite way, negative 310. 200, go all the way around. 360 plus 200 is 560. If I go the other way, I get negative 160. So you're just going either clockwise, which is negative, or counterclockwise, which is positive. And again, some genius at the time, we didn't have clocks. Well, we didn't have digital clocks, sure enough, but we didn't have, remember those analog clocks? They stopped teaching kids how to read in middle school. It's like, well, they all have a cell phone. They don't need to know how to tell time.
They made us learn that in first grade, and I thought it was the worst thing ever, and then I learned how.
Okay. All right. So find the smallest positive coterminal. So 370 went all the way around the circle, so this is a 10-degree angle. I don't need to find the negative version. The reason I don't find the negative is because I want to go between 0 and 360. If that said go between 0 and negative 360, that means the other way. Negative 135, that comes down here. Negative 135 is right here. Okay, so this comes around 180 plus 45 more. So that's 225. 750, we go around the circle twice. How do we know this? Well, we watch snowboarding and skateboarding. We know that a 720 is 2 full rotations, right?
30 degrees.
So this is
30.
somebody over-rotated 30 degrees. And if your back side, you fall on your face. Your front side, you fall on your back. So 400 degrees, we went all the way around the circle. That's 360. How many more degrees do I have to go? 40 more. And then negative 30 is down here. That's a negative 30 degree angle right there. So how would I get all the way to here?
390 degrees.
Wait.
330.
Yeah, 30.
90 degrees for the last one.
And then 90 degrees. Yeah, negative 270. Whoop, comes right to there. So that is a positive 90 degrees.
Heck yeah.
We doing all right? Am I done?
Yeah, one more.
One more. One more slide or one
If
more?
you watch the announcements, because I didn't watch it today.
They weren't done. I don't know why.
Wait, they aren't uploaded? They should be uploaded to YouTube.
No, I understand. We got an email that there was technical difficulties.
Oh, it's 'cause
That's
the
why they-
surveillance wasn't here.
That's why we said the pledge next door. Normally we say it during the video. All right, a positive acute angle that is made from the terminal side of an angle to the x-axis. I don't know what this is. So find a reference angle. That's everything we've been doing. Okay? So finding the reference angle when you're dealing in your quadrants, it's going to help you out quite a bit. So find the reference angle for each. So think about 100. Let's start doing all these different colors. We're going to get messy. We're going to use puke brown. Okay?
It's a great color.
That's a good color.
So 170 degrees is like right here. So how far up here do I have to go to get to 180? So that's 10 degrees. So that's kind of a reference angle for us. 315, let's choose a different color. That's, I don't know, that's a minty kind of color. So 315, so I go 90, 180, 270, 315 is where,
Halfway through the...
halfway there, right there. So then I have an angle coming off here. Being this angle's coming down, it's negative 45 degrees. Why was this 10? Because it came up. It goes down, it's going to be a negative for you. Okay, 190, whoop, right to there. There's our negative 10. It's coming down. 240 comes all the way around to like here. Okay, so I don't base it off of this. I say, how far did I go off here? It came down negative 60. 60 degree reference angle is its own reference. When it happens in quadrant 1, it's its own reference. And then the reference, how much further do I have to go to get to 150? And that's 30 degrees. Okay, and this all bases off, those values start basing off our 30, 60, 90, and our 45, 45, 90 right triangles. Okay, is that it?
Yep.
Yeah, buddy. All right, so I think worksheet trig B is right in line for Monday. And then if you need more time on that test, that's fine. There's only a few of you. My 8th period, I had about 80% finish it. In this class, I had about 20% finish it. So I don't know what I did different with you guys. I'm sorry.
What was the average?
F.
Anything make sense?
F minus minus.
I actually would not be surprised.